Okay, so now I'm going to get a little bit more into details about how this thing works. So you may be wondering, how did I hook the Lego motors up to that? That, by the way, is an Arduino Uno. And, well, first of all, I obviously used the appropriate, like, transistors and such. The motors are running on plain old 9 volts, just like they're supposed to, just like they run on the 6 AA batteries in the official Lego products. So, if you do the math, 6 AA batteries gives you 9 volts. So, what I did is I did a little bit of hacking / reverse engineering, I guess you would say. And I found out that the two, if you look, there's 4 conductors on a Lego Power Functions cable. The 2 outer ones supply the same polarity all the time, and those will power things like the remote control modules and things like that. The inner 2 connectors can be swapped polarity by either flipping the switch on your battery box in the other direction, or sending a different command on your remote control. So I took those 2 wires. Those 2 wires would be the ones that are connected to the motor. The outer 2 wouldn't be. They'd only be connected to electronic things. So I took those wires, I stripped them, and attached them together with regular wires, which I then ran into my breadboard with my basic MOSFET setup right there. See, you've got the MOSFET, the motors, ground wire to the drain or something, and then the source wire to ground. Forgive me if I got that mixed up, but trust me, it does work. You've seen it. And I've got the that connected to with a pull-down resistor, so that it doesn't go nuts at random times. And then I've got the gate connected right there, from there to there. And as for power, I've got this little mini breadboard thing, which I'm planning on actually soldering together one on a perf board. But I've got my 6 AA batteries running here. I've got a switch, I've got a fuse, a diode in case I hook it up backwards or something. Unlikely, but never hurts to add extra protection. I've got a big cap here mainly because I've got 3 different motors, and some of them are being controlled by PWM. If you don't know what that is, then, well, go to the Arduino website and look it up. Because if you've got access to this video, you've got access to that website because this video is online. So anyway, ignore those resistors. Those were for another experiment. That's the voltage regulator. It's made by Dimension Engineering. It's a switching regulator, which means it's more efficient. It takes care of all the complicated stuff that's involved with a switching regulator. They've got a number of products for hobbyists who don't necessarily want to get down to the component level of things in terms of their power supplies. So I definitely recommend that. And right here, we've got the display. It's made by SparkFun Electronics. You can really Google that. This is their serial 7-segment 4-digit display. And the reason it's called serial is because it's hooked up to the serial port on the Arduino. See, it's coming out of the TX, going into the RX line on this thing. And I sort of stuck it in this little Lego mount-up thing, which I'm probably going to use in my final project to mount it because it doesn't have mounting holes. This means you don't have to worry about multiplexing the display or like doing anything like that, so you know, it takes the complicated legwork out of that. So all you gotta be able to do is program the software, but you don't have to mess with the hardware as much. Some may say that that takes the fun out of making your own devices, and for those of you who say that, well, if you really want to build a device that controls the display down to the component level, go for it. So my light sensors are all just variable photoresistor cells. So the photocells are forming a sort of voltage divider circuit. So one side of the photocell is connected to ground, the other side is connected in the middle of the voltage divider, where a 4.7K resistor is connected to the 5-volt line. And then a wire right in the middle of that, right in between those two things, goes to the Arduino, to one of the analog inputs. And by using the serial output option with my computer, I read the values and determined what would be good trip points, so to speak. So I would actually put a ball in it and see what the serial monitor showed me. For more details, I'll make a more in-depth video about the Arduino itself if you want to, but this is about me building the game, not about the individual components. I'd be talking all day. So I've got this thing up here. Because this is something that I plan on keeping for a long time, I did do some modification with the Lego parts, such as stripping the wires on the connector, for instance. And honestly, that was the hardest thing for me to do because those things are kind of expensive. I mean, comparatively speaking, when you're talking about connectors, but then again, they're a lot more foolproof than most anything else that's electronic, hobbyist based. So I've got this ball lifter thing here. I decided against using the rotating piston thing that a lot of people use for their marble machines, mainly because I figured a design like this would be a lot less likely to jam up, and if it did jam up, it would be a lot less likely to damage itself in the process. So I've got this up here, which basically is just a guide, brings the balls back to here, light sensor to let the game know that there's a ball up there. That ensures that if a ball drops out, the game's never gonna spin this and think there's gonna be a ball on the board and then just sit waiting for it forever and have the game basically be the game basically be over because it never gives you another ball. So that's why I put that light sensor up there, so that it would know that there's balls to drop. And in there obviously is another light sensor. This thing, I've gotten it to move pretty smoothly. When I build a wooden chassis, I'm probably going to install something to, getting the lever through the chassis is gonna be a little challenging, like drilling a hole for it and all that, like a groove. But when I do that, I might have something where on the outside of the chassis, the handle actually sort of lifts this up a little bit, so that it's not gonna feel like it's getting stuck at any points, because occasionally at certain points it feels like it's getting stuck, and I want other people to be able to play this without fear of breaking it. So, these would be people I trust, not like a 4 or 5-year-old I don't know, because who they might be banging the machine or shaking it or something. Maybe you should add a tilt mechanism. No, I'm not gonna do that. But anyway, the other thing I'm thinking about is, where the heck am I gonna mount the boards? I want to make the things that are likely to break to be somewhat accessible. The thing is that's something that used to be really frustrating, is when I would take something apart and I would be attempting to fix it, and I find that it's, from a servicing standpoint anyway, it's very poorly designed. This is just from personal experience, but now that I'm trying to think of ways to make this easy to service in the future, and I'm sort of like having trouble coming up with good ideas for that. I kind of understand now why sometimes things aren't designed very well in terms of serviceability, especially cheaper stuff, because, you know, the manufacturer figures if it's cheaper, people won't care if it's fixable or not. And it would take extra time to make something more serviceable, and time's money in a business environment. So the faster you get something out the door, you know, the first thing they're probably going to sacrifice on, say, like a $30 DVD player, which, well, maybe not $30, but $40. The first thing probably going to be sacrificed easy is accessibility. Because who cares if a $40 machine isn't easy to get into? So, I mean, oftentimes when I take apart stuff that cheap, it's more just out of curiosity to see how it worked, not necessarily as attempt to repair it. But I don't know, I'm getting off topic here. So yeah, I sort of worked on this over the summer, and I was hoping to actually have it done, but to this point by the end of the summer, but no, I didn't get that far. I got the mechanics done, and then I just sort of lapsed, and now I'm working on it more, and I'm hoping that I'll be able to show it like in its fully built state, and, you know, have other people actually play it. So this is how I've built this thing is made out of Lego tank treads, along with these things in there. They're the little blue clippy things that have the cross hole on the other half of it. And I just had them 2x2 with a little one of those sleeve thingies on it. So the motor just runs and picks them up. It's a simple design. I mean, the only thing is that the Legos holding this thing in place are going to be under a relatively high amount of tension, I guess you would say. So you do want to kind of build it strong there. And I sort of like had had like one half of it built, and then the length of this thing just sort of hanging down, and I sort of started building long pieces until I got to a point where I could put a Technic Lego block with a hole in it through there, and then I started sort of overbuilding it so that it would stand up. And these little half things are, if a ball gets like this, here, I'll actually demonstrate. I'll remove a ball, and I'll put someone up there. I'll just remove that. See, it drops off to the side. Now, why you want that is because if two balls end up here, oftentimes they'll get stuck like that. Now, luckily, in this case, one of them did roll by, but I found that a lot of times if two balls got on there like this, they would get stuck. So I added those little things afterwards to prevent that from happening, or at least reduce the likelihood of that happening. So this thing right here, I've got some of them. This is the only thing running at full speed. The other things are actually PWM'd, so that this thing, I did that because if I ran it at full speed at 9 volts, occasionally the balls wouldn't fall down into the thing fast enough, and it would sort of jam up. Or the balls, if there were only 2 balls left, then it would like like the ball just didn't fall down fast enough, and it would just sort of be pushed back. So I slowed that down a little bit by PWM. Again, I figured out the good speed by experimentating. So then to put the light sensors and such in, I pretty much use Lego Technic pieces with holes in them and sort of glued them in. Because again, this is something I plan on keeping for a very long time. So that's why I was willing to do a little modification with Legos that ordinarily I've been really really not wanting to modify my Legos at all. But now that I'm building something that I want to keep for a long time, I'm doing that. So anyway, that's about it for this. Thanks for watching. Bye.